We are going to see about what happens during the third week of the embryonic development. The process gastrulation, the process which is known as gastrulation, takes place during the third week of embryonic development. So what is gastrulation? The process by which the bilaminar germ disc gets converted to trilaminar germ disc is called gastrulation. And that embryo which has 3 layers is called as gastrula. So embryo with the 3 layers is called gastrula. So before discussing about the process gastrulation, we must be able to explain, or we must know what is known as primitive streak and primitive node. So the location where they develop and what are all the things which involve the primitive streak and primitive node. It is worthy to know about the primitive streak and primitive node before entering into the process gastrulation. So first of all, we must know about the primitive streak and the primitive node. So now consider this as the epiplastic cell layer. And below that it is the hypoplastic layer of cells. Of course, the epiplastic cells are the columnar cells and the hypoplastic cell layer is the cuboidal cells, consist of cuboidal cells, but for convenience I have drawn like this. Do trust me that there is amniotic cavity above the epiplastic cell layer and definitive yolk sac below the hypoplastic cell layer, but for my convenience I have removed both the cavities in order to discuss about the primitive streak, primitive node and a pre-codal blade. All those things. To discuss about all those things, I have just removed the amniotic cavity and the definitive yolk sac. So what happens? The cells in the center of the epiplastic cell layer suddenly start proliferating, leading to the formation of streak. So when you make a move from the caudal end of the primitive streak to the cephalic end, there appears a dilated bulb-like portion. And this portion, bulb-like portion, is called as primitive node. Another important thing, it is 1000 times worth mentioning that there is an area at the cephalic end of a growing baby. And this area is called as the pre-codal blade. What is the specialty with this pre-codal blade? In the pre-codal blade, both the epiblast and hypoblast are sticky together. All must know that it is only from the pre-codal blade the head and neck structures develop. So this is the primitive streak. This bulb-like portion is called as primitive node. And this portion is called as pre-codal blade, where the epiblast and hypoblast are fused together. That means even if a layer is formed in between the epiblast and hypoblast, the developing layer will be absent at the place of the pre-codal blade. So if you make a cut section here, you will find some cells from the center of the primitive streak will be going down. Of course, I will make a diagram showing the cut section of the primitive streak. But it's worth mentioning before that if you make a cross section or cut section here, you will find some cells from the primitive streak, that is from the center of the primitive streak, they will be going down. So here is the epiplastic cell layer, and below that it is the hypoplastic cell layer. So as I already said, when we make a cut section here, we will be observing some of the cells of the primitive streak, some cells of the center of the primitive streak will be coming down, right? I'll show that in this diagram. So when you make a cut section here, it will be like this. The arrangement will be like this. So the cells of the primitive streak will be flowing down in between the cell layer. So in the starting, the primitive streak and the primitive node will be full of cells like this, right? And some cells will be coming down in between. When we make a cut section, we can see that some cells, some center cells of the primitive streak will be coming down like this. But after some time, what happens? The cells within the primitive streak and primitive node disappears. So once the cells disappears, it results in a depression. So the depression of the primitive streak is called as primitive groove, and the depression of the primitive node is called as primitive pit. Of course, there is a pre-caudal plate here. I hope everybody might remember that the pre-caudal plate is the place where the epiblast and hypoblast are fused together. By this time, I hope everybody might know that this is the cephalic end of the growing baby and this is the caudal end of the growing baby. So this is the epiplastic cell layer, right? Here it will be full of cells. Of course, there will be full of cells. For my convenience, I'm scribbling like this. So what happens after some time, all these epiplastic cells start proliferating rapidly and starts migrating towards the primitive groove and the primitive pit. They will be migrating towards the primitive groove and the primitive pit. All these epiplastic cells will be proliferating rapidly and they will be migrating towards the primitive groove and the primitive pit. Of course, there will be some cells left behind. Some cells of the primitive streak and primitive pit will be left behind, right? So to know the reason for the migration of these epiplastic cells, rapidly proliferating epiplastic cells, it is worth knowing that some cells of the primitive streak and primitive pit will be left behind. So what happens? The primitive streak and primitive node cells, they synthesize special type of chemical substances which attract the proliferating epiplastic cells. So what do they secrete? They secrete substances like fibroblast growth factor 8. So they synthesize substances like fibroblast growth factor 8. So those epiplastic cells which are under the influence of the fibroblast growth factor 8, they will be rapidly moving towards the primitive groove and the primitive pit. So because of the influence of the fibroblast growth factor 8, the newly synthesized epiplastic cells will be coming towards the primitive groove and the primitive pit, and they fall in between the epiplastic cell layer and the hypoplastic cell layer. So they start falling like this. The new cell layer will be formed in between the epiblast and hypoplastic cell layer. So now what happens? The hypoplastic cell layer starts disappearing. So this is the newly formed cell layer, and in this diagram you can observe that the hypoplastic cell layer have been disappeared, right? So what happens? The epiplastic cells move medially. First of all, move medially and fall into the primitive groove and the primitive bed, and start moving laterally and form a new layer called the endoderm. What I mean to say is the proliferating epiplastic cells fall into the primitive groove. So under the epiplastic cell layer, so I am, as it is posterior to the epiplastic cell layer, I am just mentioning it with the dotted line. What happens? Those cells which fall into the primitive groove and the primitive bed, they start moving laterally. I am just mentioning it with the dotted lines because it is just posterior to the epiplastic cell layer. So like this they move and form another layer called the endoderm. So the hypoplastic cell layer have been disappeared, and the new layer called the endoderm has been formed. So from this it is clear that the endoderm is a derivative of epiplastic cell layer, that is epiplast. So once this layer, that is the endoderm, is formed, another set of epiplastic cells comes towards the primitive groove. I am mentioning it with a brown color. Primitive groove and the primitive bed. They fall into the primitive groove and primitive bed, and another cell layer is formed in between the epiblast and the endoderm. Newly formed cell layer, that is the endoderm. So these cells fall in between the epiblast and the endoderm. So I am drawing this in another page so that it may be clear. As you all know, this is the epiplastic cell layer. Just for my convenience, I am drawing cells like this. So this is the primitive streak, and this is the primitive node. Of course, the cells within the primitive streak and the primitive node has disappeared, and hence now it is called as primitive pit and primitive groove. The primitive node is called as primitive pit, and the depression in the primitive streak is called as the primitive groove. So the depression of primitive node is called as the primitive pit, and the depression of the primitive streak is called as the primitive groove. Of course, there is pre-caudal blade in the cephalic end of the growing baby, where the cells of the epiblast and hypoblast were fusing together, and there is no cells in between these two layers. So as I already said, due to the migration of some epiplastic cells, some of the rapidly proliferating epiplastic cells towards the primitive groove and the primitive bed, another layer was formed in between the cells of epiblast and hypoblast, and that layer is called as the endoderm. So the appearance of endoderm ensures the disappearance of the hypoplastic cells. So once the endoderm appears, the hypoplastic cells start disappearing, and that's what I say it ensures. As I already mentioned, after the formation of endoderm, another set of the epiplastic cells start migrating towards the primitive groove and the primitive bed. So they too fall in between two layers of cells, but this time it is between the epiblast and the endoderm. So they start forming a new cell layer between the epiplastic cell layer and the endoderm. So now let us name the cell layers. So this layer is called as endoderm, and this layer is called as mesoderm. So after the formation of the mesoderm, whatever the epiplastic cells which were left out over the layer of the mesoderm, that layer of cells is called as ectoderm. Of course, you all know that this is the primitive groove, and this is the primitive bed, and this is the pre-caudal blade. So by this time it is clear that both the endoderm and the mesoderm are the derivatives of the epiplastic cell layer. That is, both are derived from the epiblast. So another interesting thing is that normally the cells of the epiblast are held together tightly by a specialized substance called ecathedrins. Ecathedrins. But due to the secretion of the fibroblast growth factor 8, the concentration of the ecathedrins decreases. It is only due to the secretion of fibroblast growth factor 8, which is secreted by the primitive streak and primitive node cells. So the epiplastic cells from the epiplastic cell layer, after falling into the primitive streak, that is the primitive groove and primitive node, they not only strengthen the caudal portion of the baby, but also they start, once they fall into the primitive groove, they start moving laterally and forwards on both the sides. So by this it is clear that the process of gastrulation is more active on the caudal part than on the cephalic end. But what happens naturally, as the time passes, the caudal end starts losing their cells and the cephalic end start gaining the cells. So as the time passes by, the cephalic end appears larger in size and the caudal end appears smaller. So another thing is the epiplastic cells which are falling into the primitive pit. Okay, what happens? They fall into the primitive pit and below the ectoderm, and that's what I'm just mentioning that with the dotted lines. So below the ectoderm, they form a tube, they form a canal-like structure which extends from the primitive pit till the pre-caudal blade, right? So this canal is called as notocaudal tube. It is also called as notocaudal canal or also called as notocaudal process. So from this it is clear that the notocaudal tube or notocaudal canal or notocaudal process is a derivative of the primitive node. So the detailed lecture of the notocaudal tube will be discussed in the next video. Thank you. Next video will be within few days. Do subscribe and stay connected.